Hi there, this is Jacob Nash. In this video, I'm going to be reviewing some questions that have to do with Unit 3 for AP Statistics. So not the super hard unit, just about our different ways to do our sampling, experiments, etc. All right, so I'm just going to go over these and I'm going to try to do my best to explain. It already has the correct answer on there. I just didn't feel like trying to mark that out. But anyways, let's look at this first one. So an electronics store sends an email survey to all customers who bought tablets. So we know any kind of AP thing is probably a good idea to underline things. So let's see. All right, they send out a survey to customers who bought tablets. Previous month, 570 bought tablets. Surveys were sent to 300 of these people, chosen at random, and then 138 people responded. What's the population in the sample? Well, the population is always going to be the full thing. The full thing is 570. So even though surveys were only sent to 300, when you're talking about population, it's the full thing, not just the ones that something was sent to. And then the sample is just obviously what you got responses back from. So this 300 is just a complete dumb thing that's trying to mess you up. So any answer choice that has 300 in it, we know is wrong. And obviously the population wouldn't be smaller than the sample, so we know it's A. All right, clear. Gonna have to clear this every time, I guess. You can't see what I'm doing. All right, let's go on to this one. All right. Administration at a high school wants to conduct a survey of student opinion. They begin with a simple random sample of 100 students. What survey methods will produce a simple random sample? Okay, so survey the first 100 students. No, that's not random, is it? Because it's just the first 100. Might be something, for it to be random, it's got to be something that has no, like everyone chosen should um be it should be any person that goes to the school should have an equal opportunity to be involved. And the first 100, there may be something different about the early comers than the other ones. So that's why A is not right. That's not random. Survey every 10th student. That is not simple random. That's systematic. Anytime you have a TH thing. Use random numbers to choose 25 of each of those. That's not simple random. That's actually a different kind that we're not going to talk about yet, but that's stratified. But that's not simple random because we're taking some from each group that's based on characteristics. Number the gym seats. Use a table of random numbers to choose gym seats. Did it even say anything about a gym? Not every, I mean, I guess that would be wrong because not everyone would go in the gym. So everyone on the school roster, that's obviously the best answer. D is probably the like tricky one, but school roster, that means it's going to have everyone. So that's why E is the right answer. All right, let's move on. Each person in a simple random sample of 1,800 received a survey. 267 returned the survey. How could non-response? So that's not that much, right? 267 out of 1,800. That's not that much, right? How could non-response affect it? And those who did not respond reduced sample size. Small samples have more bias than large samples. That's not true. Large samples could have bias, more bias. Uh, those who did not respond caused a violation of. That's not even something we talked about. Those who did not respond are indistinguishable. So that means they aren't any different. No, they could be. Those who did not respond may differ in some way. Yeah. Those who did not respond represent a stratum. No, that's not. That doesn't even make sense. All right. Um. Oh, got two on this one slide. So just focus on the top one right now. Um. Student in Oh gosh. sorry, I have to move some things out of the way. I know you can't see it, but all right. Students in a college statistics class want to study or conduct a survey to determine percentage of students in the school who are willing to pay a fee for participating in extracurricular activities. 30 students are selected randomly to complete the survey. What's this an example of? So it's what kind of sampling? Well, it says each from those. That's the key part. So these are different groups. When something's based on characteristics, I did have a video explaining this if you want to watch it on this channel. If it's based on characteristics, grouping on characteristics, then it's stratified random sampling. If it's based on location, where they are, then that is cluster. That's the difference between those. And this one's better to do. And that's the answer. So, all right, down here, D or freeze frame. Sorry, I can't read apparently. I think I saw that D down there. A social networking site sent out a survey in which the users simply click a response to join the sample. So it's a sample. One of the questions was, do you prefer to shop online? More than that, 45,000 responded. 79% said yes. What can you conclude? 79% of people plan to shop online in 2015. No, that's how does that tell you about the whole world? No, it doesn't. Poll used convenience sample, so it tells us little. Not they didn't use convenience. There's not something easier about doing that necessarily, so that's why that's not right. They used voluntary response. Yeah, they didn't have to respond. So yeah, they just click to join. So that means they didn't have to. So that's why that's right. There, voluntary response. So it doesn't tell us that much. The sample is not too small, and yeah, that's not right either. Okay. We're cruising on now to this one. All right. Hayden from the blog Hanging with Hayden sent an email directly to her readers age 18 to 21, asked a survey question. If you had a chance, would you want to be president? Of the 1,200 ones, 567 responded, and 35% of those said no. So what does this show? Well, I really don't need to read the other choices. This isn't that hard. If there was 1,200, 567 responded, that's less than half of them. So non-response bias, it's meaningless. Right? Of course. All right. We got this again. All right. Owners of a radio station want to obtain information about the radio listening habits in their market area. It contains one city of a population of 150,000 in another city of 40,000 with towns of 6,000 each. Well, you see that sometimes the information doesn't matter. In this case, those numbers don't seem to matter because we don't see that in the answer choices. The station suspects listening habits may be different in larger and smaller cities and in the rural areas. So it splits the market area up accordingly to the survey. Which of the following sampling designs best represents the type of survey that, survey design? So what is this? So we got the key sentence is this one. So it's saying, so it splits the market area according to the survey. So it looks like that they split it based on, they split it based on the survey. And how do they conduct a survey? So it looks like depending on if it's a city or a rural area. So so Now, this one's a little bit tricky, okay, I have to say, because it's all about the wording. So you might be tempted to say that it's cluster because you might say, oh, that's based on location. Well, when we're saying location, when I say that, I don't mean like a specific location, if that makes sense. I mean like just it's kind of hard to explain. So just imagine that this is a city. There's 4 sections to it. When I'm saying location, I'm saying just a part of it. All right, just this part that's all next to each other, all in one cluster. That's why it's called cluster sampling. So it is not cluster sampling because it's saying rural urban. A city, any city is going to have probably the urban part here, but there could be rural here, more urban things, more urban things. So it's all over the place. So that would not be that's not based on location when I'm saying that. So that's not what I mean when I'm saying based on location. I'm not necessarily geographic location, but like relative location to other, like just it's if you group things that are around each other in the same location. Maybe that's a better way to say in the same location. And so we are splitting it on characteristics, whether someone's rural or urban. So that's why it's stratified. So that's a little bit of a tricky one, It's all about the wording. Had it said that it picked it out of just one location, that would be cluster. Farmer wants to determine which of the 2 brands of cow feed is better for the cows on the farm. For using the feeds on the cow, the farmer decides to conduct an experiment of 36 cows. Which of the following is plans for randomly assigning should they use? Should they choose 18 cows that are lowest in weight? Randomly assigning, it's not A because it's random you wouldn't choose based on the characteristics. No, it's definitely not A. Yeah, so that's easy. That's all we have to know. But as you can see, at random, I mean, that's just obviously an easy question. So you never know what kind of question you might get. You might get an easy one, you might get a hard one. All right, let's see this one. All right, this one looks fun, being sarcastic. Experiment is to be conducted using an environmentally safe electronic deterrent system to study the effectiveness of deterring woodpeckers from damaging trees. Okay. It can be set at 4 frequencies. They look at the reaction of the woodpeckers, So usually when there's a long thing like this, a lot of it you don't even need to know. That goes for any AP class, really. There are 48 woodpeckers, and the researcher will use 12 woodpeckers, right? So we got to say, what's that, what's that, and what's that? All right, the treatments, that's what's done to it. So it's essentially the independent variable. Response variable, that's really the dependent variable, and the experimental unit is just what you're using. What is it on? It's on the woodpeckers. So anything that doesn't say experimental unit woodpeckers, you cross that out. That's the best way to do something like this. Look at the difference. So figure out the easiest one to know. It's obvious that that's what the experimental unit is. So then it's a matter of what's the treatment, what's being done. Holes aren't not being put in the tree. That's what they're trying to stop or trying to investigate. So that would be the response variable. They're doing different frequencies of the deterrent system to see if it has an effect on that. So there you go. Not as hard as it seems. Okay, we still have more. I don't remember how many questions there are. I think like 20 or something. And I do have a couple free response type ones that we can look at in a minute. I know this video is probably annoying, boring, and long, but too bad. That's just what it has to be like. A study compared daytime, nighttime counts of all these different things in 7 lakes, all right? Like I said, when it's long, you really kind of just skim because it's just a lot of pointless stuff. I mean, look, it's just let's just look at the final thing. Determine whether it is observational or an experiment. All right, so that's what we're looking for. So all we have to do is go up here and look for that. Right. A biologist should consider the eel behavior and susceptibility, being seen at night vary a great deal between daytime and nighttime. So they looked at daytime and nighttime. But in some lakes, they are not seen during the daytime. Okay. Well, did you ever hear them say they took a sample? No, they just counted them. So if they didn't take a sample, it could not be experimental. I don't think it's ever going to say the answer will ever be unable to determine. Is it because they're only watching it during the day? Well, that's not even true, but that wouldn't matter anyways. It's observational because they're not taking a sample. Right. Oh, so cool. So now we're looking at FRQ question here. A researcher is interested in determining the effectiveness of new medication that may reduce blood pressure for individuals that have higher than normal blood pressure. To determine the effectiveness of the medication, they use 240 volunteers of high blood pressure. Volunteers are assigned 50 milligrams of medicine, 100 milligrams, or a placebo. Placebo is something that is supposed to look and be like the treatment, but it's fake and it doesn't do anything. And the reason why they do it is because they want to see is the effect really because of the medicine, or is it because the person thinks they're getting medicine? That's the point of placebo. It's not always just medicine, but in this case it is. Subject's blood pressure is measured at the beginning and end. So we just got 4 parts here. I'm just going to go ahead and move this thing. And let's see. So the first thing was identify the subjects, treatments, and response variable. The 240 volunteers are the subjects. The treatment are these things, all 3 of those things, 50, 100, or placebo. And the response variable is the blood pressures, is the blood sugar levels. Yeah, that's not correct. It's not supposed to say sugar, it's blood pressure levels. So there you go. Then what's an advantage of using random assignment? So you got to say that advantage is that any potential difference between members of a lesser wait. Sorry. Let me just read that straight. An advantage of using random assignment of treatment is that any potential difference between the members has a lesser effect on the results of the experiment, since each member has an equal opportunity. So that's basically what you would need to say, that everyone has an equal opportunity, which improves results, accuracy of results. What is an advantage of using placebo? One advantage of the placebo is the effects of the participants that is that those I don't know, I don't like the wording of this. One advantage of the placebo is that the effects of the participants that make the results inaccurate are limited, because since the participants do not know, they are actually not getting a treatment. If they did, the results might change because of this knowledge. Placebo serves as a control, which can be compared with the experimental group. So it's like a control group, basically. So that's what you need to know. The advantage of it is that it improves accuracy because like I already said earlier, it makes you know, okay, is the effect of this medicine really because of it, or the fact that someone thinks they're getting medicine? A disadvantage of using volunteers is that there may be a difference between volunteers with high blood pressure and non-volunteers. This difference makes the sample not fully representative of the population, decreasing accuracy of the results. Okay. Getting there. Got still think 6 more to do. Not all FRQs though. All right, let's do this one. This one seems like a little shorter one. That's better. That's better, right? A surveyor randomly interviewed 62,348 people who live in Florida to gather information on whether national healthcare is accomplishing its goals. What are the population in sample? That's the first thing that it says. All right, let's answer that. The population of the survey is the full population of Florida, which the 62,348,000 sample, 62,348 sample is intended to fully represent. The sample are the people interviewed. So the full population is the population is the full population of Florida, and that is the sample. So it's kind of just worded in a dumb way. All right, now it says, survey found that 74% of males and 83% of females visited a family doctor at least once in the past year. Do you think these approximations are close to the approximations of the entire population? So it's saying, is this survey accurate of the whole population? It can be assumed that the approximations of the sample are close to that of the entire population, since the sample is large and randomly chosen. That's why. Had it not been, then it wouldn't be. Information was not given about whether the interviewer stayed in one region of Florida or not, though. Location could be a confounding variable, which would impact the results if applicable. So basically, we're saying we're saying yes because it's large and randomly chosen, but we're also at the same time saying we don't know, did they stay in one location, do a cluster sample? That then it may be a confounding variable, which we know. Confounding variable is basically another independent variable that you didn't want to happen, something that's affecting the results that you didn't think about. Okay, sorry for those kind of dumb explanations, or whatever you would say. All right, let's continue with this. Automobile motor oil is either synthetic or conventional. Experiment is to be conducted to determine whether mileage for an oil change is needed for both types of oil. So whether it is mileage before an oil change needed for both. It was determined that the car age is associated with frequency of oil changes, but not car size. So age, yes. Size, no. So we're saying that we're trying to figure out if the type of oil, which really is the independent variable, would affect whether you need mileage. But we're just told that age has an effect. So this is a confounding variable. This is not, so that it's basically pointless. It's kind of just trying to throw you off. What would blocking be used best for? I already made a video on this channel about that. Blocking is simpler than it might seem. Blocking, all it is separating your sample into groups based on something that's a confounding variable. That way you can block the effect of it. It's that simple. So age, we are told, is a confounding variable because it said it's associated with it. So we would block by car age. It's that simple. You just block by whatever the confounding variable is. All right, from 1990 to 2000, the American Medical Association conducted a study on patient fatigue and medication for depression. Fatigue decreased with each increase in dosage, but it also decreased with every decrease in dosage. As if it's assumed that the patients knew the study was in progress, what was this an example of? So it's basically saying that fatigue decreased no matter what. So that proves that it was only decreasing not because of the medicine, but it was decreased because they knew they were getting medicine, but little did they know, some of the time they were actually getting a decrease in dosage. That's the placebo effect. That's where something happens only because of some kind of mental thing that it just has to do with a mental thing, like someone thinks they're getting something, so it makes something change, makes them think that they're changed. All right, people have done that before to sports players, like given them something but it was actually not. I can change color, I'll do that. All right, anyways, banana tree type 1 had 135 bushels last year. This year has 167 bushels. Researchers do not know whether a difference is a result of superiority of banana 2 or the drought. Is this an example of confounding variable? Because we're not sure. Confounding variable is something else that it affected the dependent variable that you didn't think about. So drought might be the result, or it might just be because banana 2 is better. A cell phone company is trying to find a waterproof cell phone case to its product line, to add to its product line. Company managers know that plastic and silicone will be used. They also know the depth of the water. And more than 20 feet affects the waterproof case. An experiment will compare a combination of all these choices. The cell phones will be subjected to each treatment, with one dropped in water without a case, and one group dropped in the water without a case, and all phones will be scored for quality. What is control? So the different depths, there's less than 5 feet, between 5 and 20, and 20. So less than 5, got 5 to 20, and then more than 20. And we see that there's some with they're trying to see what are they trying to do here? Let's see. Cell phones will be subjected to each treatment. Dropped without a case. So first of all, it's saying what is the control? Let's talk about what is the control in the first place. The control is so we have two groups: control group, experimental. Experimental is what actually you do something to. So the control group is what is left natural so that you compare it with the other one. So they're trying to see, I guess, which one is better, silicone or plastic. But no case is would be the control group because it's the thing that's in its natural position that would be compared with the other ones. You have to have something to compare it to. All right. All right, that was a repeat. And oh my gosh. Too many questions. Sorry. All right, let's keep doing these. All right, I think there's like 5 more. Dang. Do teenagers prefer yellow or pink candy? 2 different supplements with which have no effect on taste are used in identical candies to produce pink or yellow candy. Volunteer teenagers are assigned randomly. Participants are asked to rate the candy. Is blinding demonstrated? What is blinding? Blinding is when someone doesn't know about something. So if it's just double blind, that means that the researcher also doesn't know, but they know. They can obviously see if it's yellow or pink, so there's not. So we know it's not. No, because they're not, that doesn't even make sense. That contradicts itself. No, because they do know. So it's not blinding because they do know. Right? Yeah, we have 5 more, right? All right. Let's plow through these real quick. All right. An educational company representative speaking on local news has advocated high school students download a particular app on their phone. The individual cited a study of 800 randomly selected high school junior and senior students that reported that students who downloaded the app scored 50 points higher on a standardized test than those did not, which is true. Okay, basically. Because downloading the app seems to improve standardized test scores, the app should be effective for middle school students. No, we cannot say that because this is what we call a correlation. Correlation, there's 2 different things: correlation, experiment. Correlation is when you're just naturally observing something. So all you did was tell them to get the app, and then you observed that they got 50 points higher, right? It's not an experiment. Experiment is if you actually had an experimental group and control group, like I said, and you manipulated something yourself. You're not just naturally observing it. For that, you can say that something causes something else. Not for this. So we cannot say it would also be effective for middle school students because we can't even say for sure that it's effective for high school students because you never know. There could be a confounding variable that we're not thinking about that's making them score higher. Downloading the Apple calls, that's the key thing that is definitely a big thing not to say. Calls, no, it would not calls because it's literally just an observation. The study is an experiment, no. There seems to be a relationship. Yes, there seems to be a relationship. We're not saying there is, there seems to be. Sample size was too low, no. Teenagers signed up to be subjects for a psychology experiment. When they arrive, they are told that the interview is running late and they are left in a waiting room outside. The experimenters have placed a sign near the entry door that says, "Do not open the door under any circumstances." Some subjects are outside alone and others are in pairs. These are the treatments being compared. Will the subjects open the door? Will the teenagers agreed to take part in an unspecified experiment, and the nature of the experiment is explained to them afterward. So it's an unspecified experiment. They're told after. That's called a debrief. I get mixed up because I've made some AP psychology videos too. I don't know if debrief is something you need to know for AP statistics. But I'll just say it anyways. Debrief is something when you tell someone what was happening after. So after you're done with the experiment, you tell the person, okay, this is what I just did. And then they're like, ha ha ha. Like they might have not exactly known, but unspecified. And informed consent. Now it's saying, does it have the meet the requirement of informed consent? We have to do these things. We have to have informed consent, and we have to have debrief. Due to the American Psychological Association, it just says that we have to. Informed consent is they must know what they're taking a part in, and they must have a choice. It's unspecified, so it does not meet the requirements. Of course, they voluntarily did it. That's one thing. They had a choice, but the thing that makes it not meet the informed consent, I can't even talk, is the fact that it was unspecified. All right? Got 3 more to do, right? Okay, so here's the ones that we all love, the Roman numeral ones, those freaking ones. So a study showed that people that take B12 vitamin daily are have a significantly better chance of protecting against Alzheimer's disease than those who do not. What is correct? So whenever you have this, you just have to do check X, okay? Because all the answer choices are going to have all the combinations. Don't look at the answer choices. Just do check X, or check X, whatever it might be. This study provides evidence that taking B12 vitamin contributes to protecting against Alzheimer's disease. That's another one of those things. Correlation does not mean causation. Did they do an experiment? No, so you can't say that. Only if they did an experiment could you say that. The general health conscious of people could be a confounding variable. It very well could be. That's another reason why 1 is right, not right. So those contradict each other. We know that anything that has 1 and 2 couldn't be right because they could completely contradict each other. This is an observational study, not an experiment. Well, also, 3 contradicts 1 too, because if it is observational, then definitely 1 isn't right. So you couldn't even say anything that has 1 with it. It could only possibly be, if you didn't know anything about this, it could only possibly be A, B, or D, because it couldn't be anything where there's a combination of 1 and 2 or 1 and 3. But that's besides the point. The answer would be D, because those show that you can't say that it caused it. All right. A study revealed that a strong linear positive association between the amount of shampoo and the length of hair. So there's a strong linear association, strong linear positive between those two things. Another study showed a strong linear positive association between that. So there's 2 things that are strong, linear, and positive. There's 2 things. It's saying when the data are combined, it becomes negative. What the heck? That's called Simpson's paradox. It's just it's not, in my opinion, this is kind of stupid, but you got to know it for the exam. Just the fact that's what it is. It's just something dumb. I personally can't even explain it, but somehow when you combine two data things that are positive, it's negative, and that's called Simpson's paradox. That you just have to know that. That's all you need to know about it, really. Uh, so um, let's do this last one here. Observational study. All right, so that's key. So we already know we can't say causation. Oh, and you know, if we were really running out of time, why is a conclusion not correct? The conclusion was made that a child playing extracurricular sport, they perform better. So it's saying causation. We know that's not correct because it said it was observational study. Oh, and there you go. That's E. So sometimes you can just skip ahead. You don't really need to know specifics if it's just something like that. And there you go. That's it. Thank you for watching. Sorry that was a long video.